This demonstration is a part of our submission for the course to IMN15. We are group 16, and this video is intended to aid the evaluation of the report submitted for our IoT Parking Lot project. So let's go ahead and start up the parking spot. As you can see, the parking spot tries to discover the parking broker services using Avahi. As it can find no parking brokers, it does not start up. So let's go ahead and start up our parking broker. Now the parking broker is up and running. It advertises its services, and that enables the parking spot to discover it. Now you can see that there's one parking spot available, parking spot 16, which is our group's parking spot, and it shows up as free. In order to make a reservation, we use our vehicle client application. So this is a small app that lets the user reserve a parking spot. So you can see this application has a reservation based on time. So there's currently one free parking spot. Let's go ahead and make a reservation for 8:46 a.m. So when you click the reserve button, a reservation is being made and the parking spot is allocated. So the parking spot allocated is 16. The status of the parking spot does not switch to reserve until it is time. So the status will switch from free to reserved when the timer expires, which is in 2 seconds. Yep. So now you can notice that the parking spot has changed from free to reserved, and the status has been updated here, and it has been reserved for this particular vehicle client, which is the name of the client that connected. This would typically contain the registration or the license plate number of the vehicle that is registering. So now if we try to make another reservation from another client, it should not let us do so. Let's check if that happens. So we are connecting another vehicle client, and as expected, it shows that there are no parking spots available and the reserve button is disabled. Let's continue our demonstration. So the process of billing starts at the time entered by the user. That is, when the parking spot switches from free to reserved, the billing process begins. Let's go ahead now and set the status of the parking spot to occupied, which denotes that the user has occupied the parking spot. The color changes and the occupancy status has updated to occupied. So the billing is done on per minute basis at this rate. So let's wait for 1 minute. In the meanwhile, let's take a look at the broker application, which is the crux of the project. So this application was built on Python. All the UIs for this project were built using Python TK. And all the communications between the processes, for instance, the broker communicates with the Wakama server using pipes, as we can see here. This is the service advertisement. So the broker initiates a service advertisement first and then initiates the main server process. The main server process looks something like this. So at the beginning of the main server process is the starting of the server process. So that initiates our Wakama server, which is the LWM2M server, as a sub process, and we have established pipes to the std out and std in of the Wakama server. So that lets us interact with the server just like a user would do through the command line. So after establishing pipes with the main server, this application proceeds to get a list of the clients which are connected to the server by performing a list function. Then the client list, after updating, it initiates the clients manager. The clients manager basically places observe calls for new clients and gets rid of the old clients that are no longer connected. That is followed by the observer function. The observer function is used to parse the notifications from the clients for which we have subscribed to. That is for the resources for which the observe calls have been placed. Those notifications are processed here and updated. The number of free spots are computed and updated regularly to the vehicle clients that are connected. The reservation checker checks for reservations being made from the vehicle apps. And the allocation manager here, it makes allocations to the vehicles. As you can see, our application does not let the user to pick the parking spot. Rather, it decides which is the best parking spot based on the reservation times. The reservations are based on time here. And the slots are typically fixed for 2 hours. So when a user reserves a parking spot at 8 o'clock, he's automatically deregistered from the parking spot at 10 o'clock. And the parking spot manager, it goes through the reservations and sets the reservation status to reserved when it is time. So when the system time matches the time of reservation of the client, the status is set. And the billing process also begins at that time instant. Now it's been a couple of minutes. Let's go ahead and switch the status of the parking spot from occupied to free. That should terminate the billing process. Yeah. So now the parking spot has switched from occupied to free, and the client name has disappeared, and the number of free spots has been updated to 1 back again. So upon clicking the exit button, the user gets the bill amount. So this concludes our demonstration. However, we can show an example for a deviation case that can be detected using our method. So when the parking spot is occupied without a reservation, the status of the parking spot switches to occupied, but as you can see, there is no vehicle registered to that parking spot. So this indicates that the parking spot has been occupied without authorization, that is, without making a prior reservation. The interoperability between the parking spots and our broker was demonstrated on the 13th of January by connecting it to the parking spots from groups 22, 14, and 19, and we were able to successfully reserve their parking spots from our broker application. So this concludes our demonstration of our project. Thank you.